solve equations involving surds, indices, and logarithms. Firstly, let's look into indices. What is indices? Indices are the type of number that has a as the base and x as the power. The base can be in number or a variable, and x is the power. So there are three methods that we can use to solve index equation. Firstly, by using the properties of a to the power of x equal to a to the power of y, or by taking log of both sides of the equation, or we can simply use the method of substitution. For better understanding, let's check out the examples that we have here. Example 1. Find the values of x which satisfies the equations 27 to the power of x plus 1 equal to 9 to the power of x minus 1. If you can see here, the bases for the both sides are not equal. For the left hand side, we have 27 as the base, and for the right hand side, we have 9 as the base. What we can do here is, we need to try to change the base if possible, so that we can compare the power to find out the answer. 27 we can change into 3 to the power of 3, and 9 we can change into 3 to the power of 2. Now we can solve the power. Becomes 3 to the power of 3x plus 3 equal to 3 to the power of 2x minus 2. And now, if you see here, the bases for the both sides are now equal, so you just can compare the power here. We can have here 3x plus 3 equal to 2x minus 2. Now solve for the x, you get x equal to negative 5. So, the method we use here is compare the power if same base for the method number 1. Now for the second example we have here is 3 to the power of x plus 1 equal to 4 to the power of 2x. If you see here is, the bases for the both sides are not equal, and there's no way that we can reduce the base. What we can do here is by taking log of both sides. This is the case when the bases of both sides are different. Then we can solve using the logarithm properties. By taking log to the both sides, we have here is log 3x plus 1 equal to log 4 to the power of 2x. By using the properties of logarithm, the power we can bring forward so that we will become like this. X plus 1 multiplied with log 3 and 2 equal to 2x times log 4. Now, you can expand for the left hand side, becomes x log 3 plus log 3 equal to 2x log 4. Now you can rearrange that. Becomes log 3 equal to 2x log 4 minus x log 3. For the right hand side, we can see here is, you can try to factorize out the x that we have here. Like this, becomes x times 2 log 4 minus log 3. Now you need to rearrange x as the subject. For the left hand side, becomes log 3 over 2 log 4 minus log 3, and you will end up with the answer for the x, which is x equal to x 0.656. Can you tell me what method that we are using here? The method number 2. By taking log to both sides if these are different. Now we are moving for example C. 5 to the power of 2x plus 1 equal to 6 times with 5 to the power of x minus 1. In this case, we can see that there are some terms are similar. But before that, we can try to change the 5 to the power of 2x plus 1, 5 to the power of 2x plus 1 equal to 5 to the power of 2x times with 5 to the power of 1. So, in this case, 5 to the power of 2x will become 5 to the power of x times 2, or to the power of 2. So, 5 to the power of 2x plus 1, we can rearrange, becomes like this. 5, 2x minus 6, 5x plus 1 equal to 0. In this case, we can see that 5x are the similar terms that we can see here. So we can let the 5x becomes u, a new variable, to make it simpler. Then it becomes 5u squared minus 6u plus 1 equal to 0. And then we can factorize for the equations to solve for the u. 5u minus 1 times with u minus 1 equal to 0. And then u will become equal to 1 over 5 and u equal to 1. Next is, you need to rewrite the 5x equal to u so that 5x equal to 1 over 5 and 5x equal to 1. For the left hand side, if you notice, 1 over 5 is 5 to the power of negative 1. So in this case, we can try to compare the power that we have here, since the bases are similar. So, x equal to negative 1. For the right hand side, 5 to the power of x equal to 1. If you notice here, 1 is actually 5 to the power of 0. We can see that the bases are the same, so we can just compare the power. Hence, x equal to 0. So, can you tell me what's the method that we are using here to solve the indices? Yes, it is method number 3, which is we can use substitution if we have similar terms in one equations. So that's all today. Thank you. Well done.
In this video, we're going to learn about solving equations involving sets. The symbol of sets are such the examples that we have here. You can see here we have set 3x, set 2x minus 5, and etc. In solving sets, we can remove them by squaring both sides. Remember, if we have set x squared, it must be equal to x. So, we should have the idea that by squaring any sets, we can get the original number. For better understanding, let's look at examples that we have here. Example 2. Find the values of x which satisfies the following equations. We have set 2x minus 1 minus 5 equal to 0. First step is, we need to consider only one set on the left hand side. So, for the minus 5 that we have here is, you need to move that to the right hand side, so that we can have set 2x minus 1 equal to 5. So, the idea is, we need to eliminate the set we have here. So, you can just square it both sides. So, you will end up with 2x minus 1 equal to 25. Then you solve for the x, you will get x equal to 13. Next, for the example B, we have set 3x plus 1 equal to x. Like we did before, we can just need to consider only one set on the left hand side. So for the plus 1 that we have here, you need to move that to the right hand side. So you will have here set 3x plus 1 equal to x minus 1. The usual step that we can use here is, you can just square it both sides. So you will end up with 3x plus 1 equal to x squared minus 2x plus 1 after you expand the bracket that we have on the right hand side. So we'll have x squared minus 5x equal to 0, and then you need to factorize that to get the solution of x equal to 0 and x equal to 5. If you end up with two answers for the x, you need to check the solution by substituting the answer back into the original equation. Then you can compare the answer for the right hand side must be equal to the answer for the left hand side. In this case, we can have x equal to 5 as the final answer. The keyword that we have here is you need to recheck. Let's look at the third example that we have here. Set x plus set x plus 2 equal to 2. In this case, we have two sets. It is slightly different with the examples that we have before. So in this case, you can just move one of the set that we have on the left hand side to the right hand side. In this case, I move the set x to the right hand side. So we'll have here set x plus 2 equal to 2 minus set x. After that, to eliminate the set that we have here, we can just square it both sides. So you will have x plus 2 equal to 4 minus 4 set x plus x. And then we have 4 set x equal to 2. Back to our step that we have before, we can just write only one set on the left hand side. In this case, we can move 4 to the right hand side. So we'll have here set x equal to 1 over 2. Then, to eliminate the set that we have in these questions, we can just square it both sides for the equation that we have in this question. So the answer is x equal to 1 over 4. To summarize the lesson we did today, when we are solving set equation, first step is write only one set on the left hand side. After that, you can square both sides of the equation to eliminate the set that we have in the question. Next is, you can solve the resulting equation. After that, you need to recheck the final answer by substitute back into the original equation. Remember, if you have more than one set in one equation, you have to square it until you eliminate all the sets out. Only then you can solve your equation. That's all for our video. Happy learning! Now we are going to learn about logarithms. There are few tips for solving logarithmic equation. Firstly, for the single term, you can change into the index form. Log x base a equal to b, you can change into x equal to a to the power of b. How can that be happen? For this one, you may see that the base for the log is a. So, this base could be the base for the index form. So, you will end up with x equal to a to the power of b. Second, for the equation with more than one term, you need to make sure that the base is the same so that you can solve the equation. If not, you can change the base by using the properties of log b base a equal to log b base b over log a base b if you want to change the base of a to be the base of b. Or you can use the substitution or the properties to simplify the equation. Let's check out example 3. Find the values of x which satisfies the following equations. For the question A, log x base 3 equal to 9. In this question, we have only single term on the left hand side. So, we may change into the index form. Base 3 here, you can change into the base for the right hand side. So, you will end up with x equal to 3 to the power of 9. Hence, x equal to 19683. So, that is the answer for the first question. Next, for the question B, we have e to the power of 2 ln x minus 5x plus 6 equal to 0. In this case, we may see that the question is quite difficult. But if you know that the properties of exponent to the power of ln, we may change into the e 2 ln x may become of e to the power of ln x squared. The number in front of the log or ln, you may change, bring forward to be the power. And then for the e to the power of ln, it will cancel out and leave only x squared. So the question will be x squared minus 5x plus 6 equal to 0. Only then you can answer like this after you factorize the equation x minus 2 times with x minus 3 equal to 0. Now you can solve the equation to be x equal to 2 and x equal to 3. For the question C, we have ln x equal to 2 plus ln 1 minus x. In this case, we have 2 ln in one equation. So we may bring one of the ln to be on the same side. So in this case, I want to bring ln 1 minus x to the left hand side. So we may end up with ln x minus ln 1 minus x equal to 2. Then from here, you can apply the properties of log, which is ln minus ln will become the fraction form. So we have ln x over 1 minus x equal to 2. In this case, we have only single term of log. So we may change into the index form. But you need to make sure what is the base of the log or ln that we have on the left hand side. In this case, log e is actually the ln. So base that we have here is actually the e, the exponent. So the exponent here we can bring to be the base for the index form on the right hand side. So we have here x over 1 minus x is equal to e squared. You may rearrange to be like this. 1 minus x we can bring to the right hand side. So x equal to e squared minus xe squared. We want to solve for the x. So we can factorize the x to be out so that we have x times 1 plus e squared equal to e squared. So x equal to e squared over 1 plus e squared. So that is the answer for the question C. For the question D, we have log x base 3 minus 4 log 3 base x plus 3 equal to 0. In these questions, we notice that we have two different log with two different base. First, we have log base 3 and another one, we have log base x. For the first thing you need to do is, you need to change the base by using the properties of log b base a equal to log b base b over log a base b. In this case, I want to change the 4 log 3 base x equal to base equal to the log base 3. So we can have log x base 3 minus 4 log 3 base 3 over log x base 3 plus 3 equal to 0. Now we can see here that we have two similar terms or two similar log. So we can use the substitution method so that I want to change log x base 3 equal to y. So we have y minus 4 over y plus 3 equal to 0. Then you can solve the equation by equating the denominator, so you will have y squared minus 4 plus 3y equal to 0. If you want to solve the quadratic equation, you need to rearrange them to be in the correct order. So y squared plus 3y minus 4 equal to 0. Then you factorize it to be y plus 4 times with y minus 1 equal to 0. After that, you can have the answer y equal to negative 4 and y equal to 1. But please remember that we are not going to find the answer for the y. We want the answer for the x. So you need to change them back into the original what we let before. So y is actually equal to log x base 3 equal to negative 4. Now you can solve it by using the properties of, if you have single term, we can change into the index form. The base for the log that we have here is 3. So if you bring to the right hand side, it will become the base for the negative 4. So that you can have x equal to 3 to the power of negative 4. And then x is actually equal to 1 over 81. For another one, we have y equal to 1. So we need to change them back to be log x base 3 equal to 1. Like we did before, if you have the single term, you can change into the index form so that x will be equal to 3 to the power of 1 or x equal to 3. So that's all for our video. Thank you.